This section focuses on inheritance, a fundamental concept in object-oriented programming that allows one object to inherit the properties and methods of another. This mechanism is key for reusing code efficiently and effectively. I'll introduce some terms that are critical to understanding different aspects of inheritance. So the terms to first consider are base class, superclass, and parent class. So these are all synonymous and they all mean the same thing, and these terms refer to the class whose features are inherited by other classes. So now consider the terms derived class, subclass, and child class. So these three terms are all synonymous as well, and these are classes that inherit properties and methods from the base class. This relationship is often referred to as an is-a relationship, indicating that the derived class is a specialized form of the base class. So I don't expect you to memorize these right away, but I wanted to expose you to these terms so you understand what they are, and we'll see practical examples throughout this course. So we can also differentiate between two types of inheritance. The first being classical inheritance. So this is found in class-based languages where inheritance is defined through classes, and these include programming languages like C# or Java. Now, the second type of inheritance is prototypical inheritance. This is specific to JavaScript, and this type of inheritance does not involve classes. Instead, JavaScript uses prototypes. This refers to objects that other objects can inherit properties and methods from. It's important to note that in JavaScript, the traditional concept of classes is implemented differently. While ES6, which stands for Modern JavaScript, introduced class syntax, it is syntactic sugar over JavaScript's existing prototypical inheritance model. Understanding this helps clarify how JavaScript handles inheritance and sets the stage for using these concepts to structure and reuse code effectively. What is inheritance and why is it important? Inheritance is a concept in programming where one object can inherit properties and methods from another object. In JavaScript, this is done through prototypical inheritance, also called prototypal inheritance. It's important because it allows for code reuse, making programs more efficient and easier to manage. Inheritance is one of the 4 pillars of object-oriented programming, along with encapsulation, abstraction, and polymorphism. What type of inheritance model does JavaScript use? Prototypical inheritance or classical inheritance? JavaScript uses the prototypical inheritance model. This means objects can inherit properties and methods directly from other objects rather than from classes, as in classical inheritance. What do these 3 terms refer to? Base class, superclass, and parent class. In JavaScript, the terms base class, superclass, and parent class all refer to the same concept, the class from which another class inherits properties and methods. These terms are often used interchangeably to describe the original class that provides functionality to a derived or child class. What do these 3 terms refer to? Derived class, subclass, and child class. In JavaScript, the terms derived class, subclass, and child class all refer to the same concept, a class that inherits properties and methods from another class, with that other class being the parent class. These terms are often used interchangeably to describe the new class that extends the functionality of the original class. In programming, enhancing an object's functionality is a common task. I will initialize some objects. I'll say let user and assign this. So it's just an empty object literal. Then I'll create admin and I'll create a guest. So now consider these 3 objects that we've created. Now if we were to add properties and methods to this user object literal, and we also have the admin and guest objects, it is beneficial to reuse what we have in the user object, as they're going to have the same properties and methods. Now, the admin and guest objects are more specific versions of the user object. Now, both the admin and guest are users of the website. So we can utilize prototypical inheritance to accomplish this. In JavaScript, objects possess a special hidden property, prototype, that is either null or references another object. This reference object is also called a prototype. When you see the term prototype, think of it as interchangeable with parent, similar to a parent class from which properties and methods are inherited. So I'll add some properties and methods to this user object to demonstrate this. If this user object were to have the property of name, I'll set that to my name. Then the property of surname, so I'll set it to my last name. Email, which is Steven at StevenCodeCraft.com, is active. Say true. Now I can define some getters and setters, so I'll use the set keyword, and I'll set it to be full name. The parameter will be value. So now we'll perform destructuring, so I'll use square brackets, and I'll say this.name and this.surname is assigned to value.split on whitespace. So with the set keyword, I'll be able to use full name through dot notation and assign it to a value. So for example, it would look like user.fullname is assigned to, let's just say, Bruce Wayne, for example. So here is how we would utilize this setter. Now we call the split method on the value that is passed in, which is this string, and we split it on whitespace. So now we are destructuring it, because when we call split, this stores these strings into an array. So Bruce would be at the 0th index, and Wayne would be at the 1st index. And so that is how we set it here, and this is a clean syntactic sugar that we can use to do it all on one line. So now we'll define a getter. So I'll say get full name, and then I can just return. I'll use backticks, so I can use interpolation. This.name space this.surname. And I'll end this with semicolon. So I need to add a comma here, and then a comma after this. So now I'll add two more methods for login and logout. So I can console.log. I'll use a shorthand, so log, and then backtick this.fullname. Right, so I'm using this setter here. Logged in. Then another comma, and then log out. To log, and then tab, backtick, this.fullname, logged out. So here we see we have implemented properties, the setters and getter, and two methods. Now, this same functionality is also required in the admin object and the guest object. Now, we don't want to duplicate our code and have to copy and paste it. So there is a cleaner way that we can do this, utilizing inheritance, and specifically prototypical inheritance, or prototypical inheritance. So here, rather than having to copy and paste it, because admin is a user of the website, it satisfies that condition, we can use a special property known as proto, which stands for prototype. So it's 2 underscores, then proto, 2 more underscores, and that will be the key for this property. And we set this to user. So what we're doing here is we're saying that the parent of this object is the user object. So it's going to inherit these properties and methods. So this enables us to inherit all this functionality without having to duplicate all the code. So because admin is a more specific version, it is a derived class, it's more specialized than the user object. It's more specific. So I can say is admin is true. So here we are inheriting all the functionality of that user object, and we are also extending it. So I can also add a custom method, manage users, which is just specific to the admin object. So here I would do log, and then tab, backticks. So here we can utilize what we inherited from the user object. So this.fullname is managing users. Now we can also utilize prototypical or prototypical inheritance in the guest object. So once again, we use proto, and the user So we can say is guest, it's true. And I'll add a custom method here. So say browse content log, and I'll say this.fullName is browsing content. Notice how we are not duplicating properties and methods in our objects. If you attempt to use a property not defined in an object, JavaScript automatically retrieves it from the prototype. This concept is known as prototypical inheritance. The prototype property is internal and hidden, but it can be set in various ways, one of which is using the special proto property that we were using here. So if we didn't set it in the definition of this object literal, let's say if I were to remove this, for example, then we can also set it through dot notation. So I can do admin, proto, assign it to user. So that would work as well. So I'm going to do Command Z, undo this. So if the user object here has many useful properties and methods, they become automatically available in their derived objects. So admin and in guest. And these properties that it inherits is known as inherited properties. So the prototype chain can extend even further. So let's say if we had an even more specialized object, let me define that here. I can say let superadmin, which is an even more specific object with enhanced privileges and enhanced functionality, I can say the proto, right? So its parent object is admin. So it's referencing as a parent this admin object, and this prototype is set to the user object. So superadmin will inherit all of the properties and methods defined here in the user object, and it will inherit the properties and the method of the admin object. So let's add some more specialized functionality. I can say is superadmin is true, and I'll add a method. I'll say manage admins. I'll do log and then tab. This.fullName is managing admins. Cool. So there are some limitations to prototypical or prototypal inheritance. The first being is that prototype references cannot form a circular chain. Otherwise, JavaScript throws an error. For example, setting the user proto object to be superadmin would cause a circular reference. Now, the second limitation is that the proto value can only be an object or null. Other types are ignored. An object may not inherit from two other objects simultaneously. The value of the this keyword in methods refers to the current object, even if the method is inherited. So here, we're using the this keyword. It's referring to this current object. The admin, it's not referring to the user object. So setting a property in an inherited object modifies only that object state and does not affect the base object state. So to demonstrate that, if I scroll down here, let's say if I were to do admin.fullName and I set this to Bruce Wayne. Now, say if I log this out, I will log the admin.fullName and I will log out the user.fullName. I'll bring up the integrated terminal. I go back and I change into prototypes directory. I'll do node 2, and I'll do tab to autocomplete it. If I run it, here I see the admin's name is Bruce Wayne, and by setting it, it did not change its parent. It did not change its prototype, right? So it only affected the current object. So when I log out user, it logs out Steven Garcia, which is the value that we set when we first created the object literal. So now consider the for in loop. So we can use the for in loop to iterate over both the object's explicitly implemented properties and inherited properties of an object. So here, if I just comment this out, I will say for let key in admin. I can do log, and here I would just log out the key. Once again, when we bring up the integrated terminal, I'll clear this, Command K, up arrow, and run it. So here we see is admin. We scroll to the admin implementation. Here we see that property being defined. We see manage users, which is that specialized method we implemented, and we see all of the properties and methods implemented by its parent, by its prototype, in the user object. Now, one thing to differentiate, here we comment this out, if we were to do or utilize object.keys, object.values, or object.entries, this will return only the explicitly implemented properties for that object. It will not output the inherited properties or methods. So if I were to do log, and then I do object.keys of the admin, let's bring up the integrated terminal, up arrow, and we'll run it. So here we see is admin, that property that we explicitly defined, and that specialized method, manage users. So this will not output any of the inherited properties and methods of the prototype. So for this video, we were using the proto property, which is a getter and setter for the internal prototype property. However, in modern JavaScript, we prefer to use object.getPrototypeOf and object.setPrototypeOf. So a summary of what we covered so far. In JavaScript, all objects have a hidden prototype property that is either another object or null. If an object or method is not found in an object, JavaScript looks for it in the prototype. Write and delete operations directly affect the object itself and not the prototype. So by changing that in the derived class, it will not impact the parent object. So by changing that in the derived object, it will not impact the parent object. And the for-in loop iterates both over explicitly defined properties and inherited properties of an object, while other key value getting methods only operate on the object itself. So let's go over another example. In JavaScript, we know that inheritance is achieved using prototypes, which are essentially objects that other objects can use as a template. And we know that this process is called prototypical inheritance. So for another example, let's create an object that encapsulates common behavior and properties that are shared amongst all programmers. So I'll use the const keyword, and I'll name it programmer prototype. So it'll be object literal. We'll define a method, so an anonymous function. We'll log it. Backticks, say writing code in this dot preferred language, comma. We'll define another method, drink coffee. So an anonymous function, and we will log drinking coffee. Now we'll end this object literal with a semicolon. So now we can create a constructor function, and it will use this base object as its prototype, so as the parent object. So we'll use the function keyword, and we'll name it programmer. The two parameters are the name and the preferred language. So say let private name is assigned to name. So this is a private property. So I can say object.define properties. The first argument will be this for the current object, and we'll pass an object as the second argument. So we'll specify the property to be name. Then we'll have a getter and setter. So define the get anonymous function, and this just returns the private name, comma, then set the new name. Private name is assigned to the new name. Now we'll also set the preferred language. Let's just do that here. This dot preferred language is set to the preferred language. Now, at the bottom, we want to inherit the common behavior. Let me scroll up. Defined in the parent object. So I can say object dot set prototype of. So the first argument will be this for the current object. And the second argument will be the object, which will be the prototype. So in this case, it is the programmer prototype. So let's instantiate this. I'll say const and JS programmer equal to new programmer. So the name will be Alice, and the preferred language is JavaScript. So to better explain what we just implemented, we define a programmer constructor function that has a private property named private name. We define getters and setters, so we can access this private name through the property of name. So this demonstrates encapsulation. So we are hiding the inner details of this object, And we also set the prototype with the method setPrototypeOf. So this will allow all instances of programmer to utilize the methods built into its parent object. So all instances, when we call a programmer, will have the writeCode method and the drinkCoffee method. So now let's verify that the inheritance is working correctly by calling the methods on this JS programmer object. So we can do jsprogrammer.writeCode. You can try jsprogrammer.drinkCoffee. Now we'll log it out. So the JS programmer logging out the name. So here we are utilizing this getter to get the private name. Now we'll use the setter, and I'll set this to my name, Steven, and we will log out the updated value. So jsprogrammer.name. So let's scroll up and open up the integrated terminal with Command J. So up arrow, and we run it. So here we see the result of the writeCode method. It says writing code in JavaScript. If I scroll up, this functionality is in the prototype. Here we see writing code in preferred language. Now when we called the drinkCoffee method, this outputted the expected string drinking coffee. Now if I scroll back down, we outputted the name, so we got Alice. We updated the name and logged that out, and we saw the name of Steven. So this example showcases how to effectively use prototypes to implement inheritance in JavaScript, allowing for shared behavior and properties while maintaining encapsulation of private data. So by leveraging prototypes, the programmer object can be extended to create various types of programmers with minimal code duplication. What is the proto property? In JavaScript, the proto property is a reference to the prototype of an object. It allows objects to inherit properties and methods from another object. This property is used to set or access the prototype directly, but it is considered outdated. Instead, modern JavaScript uses object.getPrototypeOf and object.setPrototypeOf for these tasks. In JavaScript, multi-level inheritance allows objects to inherit properties and methods from multiple levels of prototypes. So consider this simple example. If I just declare an array, and I assign this to an empty array, so when my array is created, it is not just an instance of an array, but also part of a larger inheritance hierarchy. So my array is an instance of array, and array.prototype, also referred to as array base, provides methods and properties common to all arrays. Now, object.prototype, also referred to as object base, is the prototype for array base. It provides methods and properties that are inherited by all objects in JavaScript, including arrays. This setup forms a multi-level inheritance chain, where my array inherits from array.prototype, and array.prototype inherits from object.prototype. This is how the inheritance looks in a structured form. So the base is object.prototype, also known as object base. Then array.prototype extends that, also known as array base, and then our instance of the myArray. So some key points: objects created by a specific constructor, like array, will share the same prototype, in this case array.prototype. This multi-level inheritance allows objects like myArray to access properties and methods defined in object.prototype, giving JavaScript its dynamic and flexible nature. Understanding this inheritance structure helps in recognizing how methods like toString or hasOwnProperty are available to your array, even though they are not directly defined within the array constructor or on the array instance itself. This concept is fundamental to mastering JavaScript's prototype-based inheritance and helps in designing more efficient and robust applications. So moving forward in this course, we'll be using the live server extension in VS Code in order to improve our productivity and reduce our need to run our code in the integrated terminal. So click on the icon for the extensions marketplace and search for live server. So this extension allows us to have hot reloading, where it will run our JavaScript code in a web browser, and when we make a change in our JavaScript code, it will automatically update and we can see those changes without having to constantly run it in the terminal. So now that you have that installed, I'll close this. Back to our folders. I'll create a directory, so you can click on this icon, and I'll name it _practice. You can name it whichever you prefer. Now within it, I'll create a new file, and I'll name it index.html. Now I'll be creating a course on HTML and CSS, so no need to be an expert in those technologies. We just need this file in order to open up a web page with live server. I'll also create a file named index.js, and here we will place our JavaScript code for our lessons. So back to the HTML file, we need to create the boilerplate for an HTML document. So Visual Studio Code will generate this for us. Simply type in an exclamation point, and here we see Emmet abbreviation. So just do tab, and here VS Code generated this for us. So now we want to reference our JavaScript file. So within the body elements or body tags, type in script, and then type text/JavaScript. Now we will reference our index.js file here. So we'll do source./index.js as it's in the same directory. Then we will have a closing tag, and that's it. So now we'll open up our command palette. So that's Command-Shift and P or Control-Shift and P. Type in live server, open with live server. So this will open our index.html in our web browser. Now because we don't have any HTML written between the body, it's just a blank web page for now. So let me close the sidebar with Command B, and I will resize this. So now our JavaScript will be running in the JavaScript console, but we can see that in the DevTools. Also, I suggest that you use Google Chrome unless you are more comfortable with Microsoft Edge or Firefox. So now to open up the Google DevTools, the keyboard shortcut is Command, Option, and J. You can also right-click and then click on Inspect. So here, in order to get this to open in a new window, click on these three dots. And here when it says Dock Side, you want to click the leftmost icon. So this will open the DevTools in its own window. Now to see your JavaScript code, you want to click on Console. So now we can click on this settings icon to hide that. Now, in order to see and execute our JavaScript code, type in log, right, and then we'll do tab, and then hello world. Then save it, and now we see it reflected on the right side console. So we no longer have to constantly run it in the integrated terminal. So here I'll do Command and plus, so we can see the text more easily. So in JavaScript, we know that we can define an object like this by creating an object literal. Say the name and the value of Steven. We can end this with a semicolon, and we can log out this object, the person. And here we see outputted on the right-hand console. Now let's iterate through this using a for in loop. So I can do for let key in person, then log, and tab, and just log out that key value. So here we see the key of name was outputted. Now notice how only the properties defined directly in this person object are displayed. Similarly, if we use object.keys, so let's log that out, object.keys, and then the person object, we output that, we see the value of name. So this only shows the properties defined at the object's own level. So the properties that it inherited from object.prototype, also referred to as object.base, aren't displayed because of specific attributes attached to those properties. So these attributes can control whether properties are enumerable, writable, and configurable. So in other words, these attributes determine whether the property will be outputted when iterating over it, such as with a for in loop, or if using object.keys, object.values, or object.entries. So let's see this in action. I'll clear this out. And we'll examine the property descriptor for the toString method, which this person object inherits from object base. So I'll clear this out as well. And I will expand this so we can see it more easily. So we'll say let object base assign to object.getPrototype of the person object. So we're getting the parent object of this person object. Now we will do property descriptor. So this is object.getOwn property descriptor of the object base. So that parent object and the toString method, which is defined in its parent. So now we'll do log, tab, property descriptor, and we will see those attributes that determine whether the toString method will be shown when we enumerate through the person object. So let's save this, and we'll see the result in our console. Let's expand this. So we see the attributes of configurable, enumerable, what the value is, and writable. So the one we are concerned about is the enumerable, and we see the value is set to false. So when the enumerable attribute is set to false, this prevents the toString method from appearing in the output of a for-in loop and methods like object.keys. So you can also define or modify these attributes, so configurable, enumerable, and writable, for properties in our own objects. So for instance, if we wanted to make the name property here non-enumerable, you could do this. So we can do object.define property. Now the name of the object and the name of the property. And we can pass in an object where we can define these attributes. So we can say writable is false. Now enumerable is false. So now it won't show up when we do a for-in loop. And configurable is true. So let's comment this out for now. We'll expand this. So after this change, the name property will no longer appear in a for-in loop or object.keys. So let's just demonstrate that. Let key in the person object. Then we can log all the keys that are enumerable. Then we resize this. And we can clear this out by clicking this icon. You can save it. And here we see there are no enumerable keys. So no enumerable properties in this person object, because we defined this here for the name property. So by default, when properties are created directly on an object, they are writable, enumerable, and configurable attributes are set to true. This allows properties to be modified, enumerated, and reconfigured unless explicitly changed. Understanding these property attributes and their implications helps in managing how data in objects is accessed and manipulated, providing greater control over object behavior in JavaScript applications. What are the property descriptors or attributes in JavaScript that determine whether a property can be accessed, modified, or iterated over? In JavaScript, property descriptors or attributes that determine whether a property can be accessed, modified, or iterated over are enumerable, writable, and configurable. So for enumerable, if true, the property will appear during for-in loops and object.keys. For writable, if true, the property's value can be changed. For configurable, if true, the property descriptor can be changed and the property can be deleted. In JavaScript, every object has a prototype, except for the root object, which is at the top of the prototype chain. The prototype acts as a template or parent from which the object inherits methods and properties. Accessing an object's prototype. The recommended method to get the prototype of an object is by using object.getPrototypeOf. This function returns the prototype or the parent of the specified object. Constructors and their prototypes. In JavaScript, constructors are special functions used to create instances of objects. Since functions in JavaScript are objects themselves, they too have properties, one of which is the prototype property. This property is not the prototype of the constructor itself, but rather the object that will be used as the prototype for all instances created with that constructor. So for example, if I create a constructor function with the function keyword, and if I name it circle, now the code within the code block, so that will be used for instantiating a new circle object. So now, if I log this out, we know that functions are objects in JavaScript. So I can do circle, and it has a property of prototype. So if we log that out, here we see this empty object. We can expand it. This object is used as the parent for all objects created with new circle. Close this out. And I can comment this out. Creating objects and their prototype links. When you create a new object, its prototype, or its parent, is set to the prototype of its constructor function. So this is illustrated with, say if I create an object literal, and I assign this to curly braces. So this is syntactic sugar for let object equal to new object. So the prototype of obj or object can be referred to using the proto property, which is an accessor property that exposes the internal prototype linkage. So we'll just log that out. Log and tab, see the object, and then 2 underscores before and after proto. So here we outputted that. We can expand it. So this would be the same as doing, say if we do log object.prototype. So we get the same output. Close this, we expand it. So now if we were to expand it, we can expand the get, and here we see the internal prototype is object. So understanding how prototypes and constructors work in JavaScript is crucial for effectively leveraging the language's object-oriented capabilities. By grasping these concepts, developers can better manage and utilize object inheritance in their programs and reduce code duplication. Does every object have a prototype? In other words, does every object have a parent object? Every object has a prototype, or a parent object, except for the root object, which is at the top of the prototype chain. So an object will inherit the properties and methods from its prototype or parent object. Do constructor functions have their own prototype? Yes, constructor functions have their own prototype. In JavaScript, functions are objects, so they have their own prototype property, which is used to assign properties and methods to instances created by the constructor function. Optimizing memory usage with prototypes in JavaScript. In practical applications, especially those involving numerous object instances, it's important to manage memory efficiently. If each object instance were to maintain its own copies of methods, this would lead to significant memory overhead when dealing with thousands of objects. How JavaScript handles method access. To address this, JavaScript utilizes prototype-based inheritance. When a method is called on an object, the JavaScript engine first checks if the method exists on the object itself. If the method is not found, the engine then looks up the prototype chain of the object. Utilizing the prototype property. Each constructor function in JavaScript has a prototype property, which is shared by all instances of the constructor. This shared prototype is crucial for memory efficiency. So to demonstrate an example of this, we just create a constructor function, name programmer, the 2 parameters being name and preferred language. Then we use this keyword to assign it and the preferred language. So now, methods added to the prototype are shared across all instances. So I will expand this just so we can see it more easily. We can do programmer, so that constructor function dot prototype dot write code. So we can assign this to an anonymous function. And here we'll do log and backtick, so we can use interpolation. This dot name writes code in this dot preferred language. We can end this with a semicolon. We could also override the toString method for all instances. So we can do programmer dot prototype dot toString. Assign this to an anonymous function. Say programmer, this dot name, comma, language, this dot preferred language. End that with a semicolon. So now let's create an instance of this programmer. So I can say const JS programmer, new programmer. I'll say Alice, and the language is JavaScript. Now let's just call it jsprogrammer.writeCode. Now we save it. And here in the console, we see the expected output. So the advantages of using prototypes. Let me expand this again so we can see the code. The first advantage is memory efficiency. Since methods defined on the prototype are shared, there is only one copy of each method in memory, regardless of the number of instances. This is especially beneficial in applications where many instances of a class are created, as it saves a significant amount of memory. So for example, if we were going to create many programmer objects, they would all share these same methods. So write code and this implementation of the toString method. So the second advantage is flexibility. JavaScript's dynamic nature allows you to add or modify methods on the prototype at any time. Modifications to the prototype are reflected across all instances immediately, which can be particularly useful for updating functionality at runtime. And the third advantage is overriding methods. So you can easily override inherited methods by defining new implementations on the prototype. For example, the toString method for programmer has been overwritten to provide more specific information about each programmer instance. Managing instance and prototype members. So first consider instance members. These are defined within the constructor function, and these are unique to each instance, such as the name and preferred language in the programmer constructor. These properties are set per individual object and manage data that varies from one instance to another. Now consider prototype members. These are defined on the constructor's prototype, and these members are shared across all instances, like the write code and toString methods. This setup is optimal for methods that perform generic actions applicable to all instances. By strategically using prototypes to share methods among instances, you can enhance your JavaScript applications both in terms of performance and maintainability. This approach ensures efficient memory usage while maintaining the flexibility to adapt the shared behavior of objects. How does using prototype-based inheritance in JavaScript help in managing memory efficiently when dealing with numerous object instances? Using prototype-based inheritance in JavaScript helps manage memory efficiently because methods defined on the prototype are shared among all instances of an object. Instead of each instance having its own copy of the method, there's only one copy stored in memory. This significantly reduces memory usage, especially when creating thousands of instances, as all instances refer to the same method on the prototype. What are the advantages of defining a method on a constructor's prototype as opposed to defining them within the constructor function itself? Defining a method on a constructor's prototype in JavaScript has several advantages. One being memory efficiency. Methods on the prototype are shared by all instances, so only one copy of each method exists in memory, saving space when creating many instances. A second advantage is consistency. Changes to a prototype method are immediately reflected in all instances, making it easy to update functionality across multiple objects. The third advantage is performance. Shared methods reduce the memory overhead and can lead to better performance, as there is no need to duplicate methods for each instance. Understanding prototype dynamics in JavaScript. So in JavaScript, changes to a constructor's prototype affect all instances, regardless of whether they were created before or after the changes. This behavior highlights JavaScript's use of object references for prototypes. Consider the programmer constructor function. So, just create this. Takes the name and preferred language as parameters. We'll set these properties. So now, let's instantiate it. I'll set const. I'll just call this programmer, new programmer, put the name of Steven in the language of JavaScript. So now let's add a new method to the programmer prototype. So we'll do programmer.prototype.writeCode, setting this to an anonymous function, console.log, say this.name, writes code in this.preferred language. We end that with a semicolon. And let me expand this so we can see the full method. So even though programmer, this instance, was created before the write code method was added to the prototype, this instance can still access the write code method. So let's do that. We do programmer.writeCode. We can save that. And here in the console, we see the console log statement, Steven writes code in JavaScript. So enumerating object properties. So using a for and loop, you can enumerate over all properties of an object, including those on the prototype. So here we can do for let key in programmer. We'll do log. We'll output the keys. And let's comment this out for now. You can save that. Here, we have enumerated over the properties, so we have the name, the preferred language, and the method write code. So based on the JavaScript documentation, properties defined directly on the object are referred to as own properties, while those inherited from the prototype are called prototype properties. So checking for own properties. You can use the hasOwnProperty method to determine if a property is an own method of the object. So we'll see an example of that. Do log programmer.hasOwnProperty. We'll say the name, output that, and here we see the output of true. Let me comment this out. We'll clear it just so it's easier to see. So that the name property is an own method, meaning that it was defined within the constructor function. So let's see another example. I'll do Shift Option and down arrow to copy that, and I'll specify write code. So this is the name of the method or the member that was defined on the prototype. Here, when we save this, we get the value of false, indicating that this is a prototype property. So this method, hasOwnProperty, helps distinguish between properties that are part of the object itself and those inherited from the prototype. Understanding the distinction between own and prototype properties is crucial for working effectively with object-oriented features in JavaScript. This lesson demonstrates the dynamic nature of prototypes and their practical implications, providing a deeper understanding of how JavaScript handles object properties and inheritance. How does adding a new method to a constructor's prototype affect existing instances of that constructor in JavaScript? Adding a new method to a constructor's prototype in JavaScript makes that method available to all existing instances of that constructor, as well as any new instances created afterward. This is because instances reference the prototype for methods, so they automatically have access to any new methods added to the prototype, even if they were created before the method was added. What is the difference between own properties and prototype properties in JavaScript? And how can you check if a property is an own property of an object? In JavaScript, own properties are those defined directly on an object, while prototype properties are inherited from the object's prototype. To check if a property is an own property of an object, you can use the hasOwnProperty method. If this returns true, the property is an own property. If it returns false, the property is inherited from the prototype, or from its parent. While JavaScript allows you to extend the functionality of built-in prototypes, such as adding a shuffle method to array.prototype, it is generally advisable to avoid doing so. So here's an example of what it might look like. Do array.prototype, and we extend it by adding a shuffle method, assigning this to an anonymous function, and here I'll just add a comment. This would be the implementation of the shuffle. So then when we create a new array, assign this to an empty array, then I'll be able to call array.shuffle. So here, let me open up the tools. And let's just log something out. I'll just do log, and I'll say shuffle. I save that. Here is the output of shuffle. So this approach may seem convenient because we can add our own custom methods to built-in data types in JavaScript. However, it carries significant risk. So there is a potential for conflict. For example, library conflicts. If you modify a built-in prototype, you risk conflicts with third-party libraries that might rely on the default behaviors of these objects. Different implementations of the same method can lead to inconsistent behavior across parts of your application. As a best practice, do not modify objects that you do not own. This helps with maintainability and compatibility. Modifying objects that are globally accessible, like built-in prototypes, can make your code harder to manage and predict. It may also break compatibility with future versions of JavaScript or interfere with enhancements in third-party libraries. So for an alternative approach, instead of modifying built-in prototypes, consider a safer alternative. You can use a utility function. So rather than doing this, I comment that out. You can do function shuffle array. This takes in an array as parameter variable. And here you have the shuffle logic here. And then you return the array. So then to utilize that, you can simply do const shuffle array. Then you simply invoke that function and pass in the array. Now you can also extend the prototype safely. So if absolutely necessary, you want to ensure that your modification does not overwrite existing methods and check if the method isn't already defined. So, for example, you can do if type of array.prototype.shuffle. So if the type of is not a function, meaning that it's not defined, then I just copy this and paste it here and uncomment that. Do tabs. So this is an example of how you can extend the prototype safely. By adhering to these guidelines, you ensure that your JavaScript code remains robust, maintainable, and compatible with other libraries and future updates. Why is it generally advisable to avoid modifying built-in prototypes in JavaScript? It is generally advisable to avoid modifying built-in prototypes in JavaScript because doing so can cause conflicts with third-party libraries that rely on the default behaviors of these objects. Modifying prototypes can also make your code harder to maintain and predict. It might break compatibility with future versions of JavaScript or interfere with enhancements in other libraries. What are some safer alternatives to modifying built-in prototypes in JavaScript, and how can they help maintain code compatibility and predictability? Some safer alternatives to modifying built-in prototypes in JavaScript include using utility functions, where you create standalone functions to add new functionality without affecting built-in prototypes. This avoids potential conflicts and keeps your code isolated and maintainable. You can also extend prototypes safely, so if you must extend a prototype, first check if the method already exists to avoid overriding existing functionality. These approaches help maintain code compatibility and predictability by preventing conflicts with existing or future code and ensuring your additions do not interfere with standard JavaScript behavior or third-party libraries. So to summarize inheritance and prototypes in JavaScript, this section has provided a thorough exploration of several key concepts in JavaScript related to object-oriented programming. We began by understanding inheritance, including prototypes and prototypical inheritance, which are fundamental to how JavaScript handles objects and classes. We discussed multi-level inheritance, where objects inherit properties and methods across multiple levels, allowing for a more structured and hierarchical object model. The use of property descriptors was covered to control and manage how properties behave, including their enumerability, configurability, and writability. Further, we examined the distinction between constructor prototypes and instance members, emphasizing the difference in roles of each in JavaScript programming. The process of iterating over both instance and prototype members was covered, giving practical insight into how to access and manipulate object properties effectively. Lastly, we addressed best practices regarding prototype manipulation, specifically advising against extending built-in objects. This practice, while possible, can lead to conflicts and compatibility issues, especially when dealing with third-party libraries. Overall, this section aimed to equip you with a solid understanding of how inheritance and prototypes contribute to efficient and effective JavaScript programming, promoting better coding practices and a deeper understanding of the language's capabilities. What is the significance of prototypes and prototypical inheritance in JavaScript's handling of objects and classes? Prototypes and prototypical inheritance are crucial in JavaScript because they allow objects to inherit properties and methods from other objects. This enables code reuse and efficient memory usage, since methods can be shared across instances rather than duplicated. Prototypical inheritance also supports a flexible and dynamic object model, allowing developers to extend and modify objects at runtime, which is fundamental to JavaScript's object-oriented programming capabilities. How do property descriptors help manage the behavior of object properties in JavaScript, and what attributes can they control? Property descriptors in JavaScript help manage the behavior of object properties by allowing you to control specific attributes of those properties. The attributes they can control are enumerable. This determines if the property shows up in the for and loop and object.keys. Writable. This determines if the property's value can be changed. And configurable. This determines if the property descriptor can be changed and if the property can be deleted. Using property descriptors, you can precisely define how properties behave, making your objects more secure and predictable. Why is it generally advised against extending built-in objects in JavaScript, and what are the potential risks of doing so? It is generally advised against extending built-in objects in JavaScript because it can cause conflicts with third-party libraries that rely on the default behavior of these objects. This can lead to inconsistent behavior and bugs. Additionally, modifying built-in objects can make your code harder to maintain and predict, and it may break compatibility with future versions of JavaScript or interfere with updates in other libraries. A better practice is to use utility functions or safely extending prototypes by checking for existing methods.